Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video on the unit circle. So what this success criteria here is saying, we want to be able to calculate the sine, cos or tan of any angle, not just those angles between 0 and 90 degrees. So we'll start by drawing the unit circle, which will allow us to do this. So here on your screen is the unit circle. It's drawn in the Cartesian plane. Its center is this point here, the origin. What makes it a unit circle is its radius is 1. So this coordinate here would be 1, 1. Over here would be -1 and -1. So we're going to use this to calculate sine, cos, or tan values. So let's start by drawing a right-angled triangle. The right-angled triangle would be here. Because the radius of the circle is 1, this distance here would be 1. So we're going to define theta, the angle we're interested in, as the angle made with the positive x-axis. So this is the positive x-axis. So we're looking at the angle made with the positive x-axis going in this direction, an anti-clockwise direction. So let's go ahead and look at what is sine theta, cos theta, and tan theta. So we'll start with sine theta. So sine of theta is opposite over hypotenuse. So the opposite, which is this side here, so this distance will be whatever the y-coordinate is of this point. So if this point had a y-coordinate of, say, 0.6, this distance would be 0.6. So I'm going to call this distance y. Sine theta is therefore just y opposite over hypotenuse. Of course, we don't need to write the over 1. Sine theta is just whatever the y-coordinate is of this point. Remember, the y-coordinate of this point would be less than 1 because this distance is 1. And obviously, from here to here would be less than 1. So let's look at cos theta. So cos theta is adjacent over hypotenuse. So this length here is whatever the x-coordinate is of that point. So I'll call this distance x. So cos theta is just x over 1, or x. Now for tan theta, it's opposite over adjacent. So it is whatever the y-coordinate is over the x-coordinate. Note, tan theta is actually sine theta divided by cos theta. Let's actually give a value to theta now so we can calculate this. So let's say that this angle that I made before, let's say it's 30 degrees. So it turns out if you draw something like this where this angle is 30 degrees, this line here will intersect the circle at the point √3/2, which is like 0.866 half. That will be the point of intersection of this line and the circle. So we can see from this that the sine of 30 degrees is just the y-coordinate, which is a half. We already knew that. The cos of 30 degrees is the x-coordinate, which is √3/2. Again, we already knew that exact value. Now, tan theta, tan of 30, is going to be sine of 30 divided by cos of 30. And the 2's just cancel out. You're left with 1 on √3. So you knew all of these exact values. We know the exact values between 0 and 90 degrees. But we now want to use that to find exact values of the ratios where the angle's not just between 0 and 90 degrees. So we said that we were looking at theta, the angle made with the positive x-axis in an anti-clockwise direction. So at the x-axis, this would be 0 degrees. Up here, that would be 90 degrees. That's 90 degrees with the positive x-axis. Then we have 180 degrees, 270 degrees down here. And back up at 0 degrees is the same as 360 degrees. Because here, if you go full 360, you're back to where you started. So we're going to refer to the quadrant. So we call this quadrant 1. That's all the angles between 0 and 90 degrees. And then we have quadrant 2 going anti-clockwise, quadrant 3, and quadrant 4. We need to be able to calculate sine, cos, and tan values of angles in quadrants 2, 3, and 4. So let's see how we would do this. So let's now look at calculating the sine, cos, and tan of the angle 150 degrees. So again, when I refer to an angle like 150 degrees, I'm referring to the angle made with the positive x-axis in an anti-clockwise direction. So 150 degrees will be like over here. This is the angle that I'm talking about, that will be 150 degrees. But if that angle's 150 degrees, this angle here would also be 30 degrees, of course, because 150 plus 30 equals 180. So let's make up another triangle. So once again, this would be right-angled. So these two triangles here, they would be congruent. They have the same set of angles, the same set of distances. So this distance here would be the same as this distance here. So from here to here is the same as from here to here because they're congruent triangles. Now I know the distance from here to here is root 3 on 2, or 0.866. So the distance from here to here is 0.866. The thing is, however, the x-coordinate in this quadrant here is negative. So if I'm looking for this point here, where the line intersects, the x-coordinate will actually be negative root 3 on 2. So again, because this triangle and this triangle are congruent, this distance is the same as this distance. This distance would also be a half. So the y-coordinate would be a half. Note, the y-coordinate in this quadrant is positive. So I now have all I need to calculate sine, cos, and tan of 150. So we'll start with sine of 150. So remember, sine of 150 is just the y-coordinate of the point. So the y-coordinate of this point is a half. So sine 150 is also a half. Cos 150 is the x-coordinate. So instead of being positive root 3 on 2, it's negative root 3 on 2. And similarly, the tan of 150 is just a half divided by negative root 3 on 2, or negative 1 on root 3. So you saw here, sine of 150 was the same as sine of 30. For cos and tan of 150, you got the same value as cos and tan of 30, it's just the sign was different. So because we have the y-coordinate is positive in this quadrant, but the x-coordinate's not, only sine is positive in this quadrant. So when you're calculating angles between 90 and 180 degrees, only the sine of those angles is positive. Cos and tan are both negative. In the first quadrant, they were all positive, because in the first quadrant, both the x and y coordinate is positive. So down here in the third quadrant, we have a negative x coordinate and a negative y coordinate. So negative x coordinate means cos will be negative in this quadrant. The negative y coordinate means sine will be negative. But because tan is y over x, it's a negative divided by a negative. Tan is positive in this quadrant, and similarly cos is positive in this quadrant. So make up some acronyms so you remember, like all students take calculus. All the ratios are positive here, only sine in the second quadrant, tan in the third quadrant, and cos in the fourth quadrant. So I just want to quickly link this back to what we did with the sine rule. So we found that because of this unit circle, we have this rule. So sine of theta equals the sine of 180 minus theta. That's why we had sine of 30 equals sine of 150. Remember, that came up when finding angles using the sine rule. That's why there was an ambiguous case. If you got an angle of like 70 degrees, remember 110 could also be the solution. So a similar rule doesn't work for cos and tan. We saw if we took cos of 30 or tan of 30, we actually got negative cos or tan of 150. The sign was changed. So make sure you know these, because we're going to use this to calculate angles of any magnitude, which I'll do on the next slide. So if we need to calculate the sine, cos, or tan of an angle outside the range 0 to 90 degrees, we just follow this step. We find a corresponding angle in the first quadrant, that is between 0 and 90 degrees, and then determine whether our answer is positive or negative. So that probably doesn't make too much sense. Let's start with an example. We're going to calculate the exact value of cos 240 degrees. So let's start by drawing the unit circle, and after you've done this a few times, hopefully you won't need to do this. So 240 degrees. Remember, we start at 0 and it goes anti-clockwise. 90, 180, and then 270. So cos 240 degrees will be in this quadrant here. So we're looking at the angle made with the positive x-axis going in an anti-clockwise direction. So 240, we go 90, 180, and we'll be down here. So let's draw a line that represents 240 degrees. So this angle in here would have to be 60 degrees, because 180 plus 60 equals 240. So we're interested in the coordinates of this point here. So what we can do is draw like a congruent triangle in the first quadrant. If I draw a triangle here, like that, it'll be the same triangle as if I draw it like this, as long as the angle is the same at 60 degrees. So cos 240, its corresponding angle is 60 degrees in the first quadrant. So we know that cos of 60 degrees is a half. We need to know our exact ratios here. So cos 240, well, this distance here will be the same as this distance here because they're congruent. So cos 240 will also have magnitude of a half. We just need to decide, is this going to be positive or negative a half? So remember, all are positive in this quadrant: sine, tan, and cos. Cos is negative in this quadrant. The x-coordinate here is negative. So cos 240 is negative a half, and we're done. So please pause and copy this down. If you need, we'll go through another example now. So let's now calculate the tan of 13 pi on 4 radians. So people tend to like to work in degrees a lot more. So we can simply convert 13 pi on 4 into degrees. So of course, remember, to go from radians to degrees, you times by 180 over pi. So then here we can cross out the 2 pi's, and of course 4 goes into itself once and goes into 180 45 times. So we actually get that that is equal to 585. We're actually being asked to find tan of 585. So you might be sitting there thinking, wait, doesn't this thing only go up to 360? So when we're at 360, what do we do there? Well, if we want to do 585, what we can do is we can go a full 360, and then we can go another 225. So there is this rule with angles of any magnitude. Theta is any angle is equal to that angle plus 360. So like 10 degrees and 370 degrees are treated as the same angle. You can also subtract 360 or multiples of 360. So like the angle 200 and the angle negative 160 are the same. So make sure you keep that in mind. It is commonsensical though. Tan of 585, we can just go 360 plus another 225. So to calculate the value of this, as I said, it's going to be the same as tan 225, which is going to be down here. So let's draw our line. It will be this angle here, 180 to here, plus 45. So it turns out tan of 225 is going to be corresponding to tan of 45. 225, its corresponding angle in the first quadrant is 45 degrees. Now we just have to determine whether the tan at this point will be positive or negative. So remember, it goes all students take calculus, all in this quadrant, sine in this quadrant, tan is positive in this quadrant. Tan is positive because the y and the x are both negative. So this is actually going to be positive. Now, we know that tan 45 is equal to 1, positive 1, so tan 225 is also equal to positive 1. So that's how we can do it using the unit circle. Hopefully, after a while, you won't need to draw the circle anymore. All right, sorry for the long video. Thanks for watching. This has been the luckiest maths teacher in the world. Have a great day.